Alright, here's your last video for functions day 1. We are going to look at what we call combinations of functions. So, there are 4 basic operations. There's addition, where we are just going to add the 2 functions together. Subtraction, where we subtract the 2 functions. Multiplication, and division. We are mainly going to focus addition, subtraction, little multiplication. But you need to be very careful about your domain, especially when we have denominators and square roots. If you need to pause the video to write this down, you may. A composition of functions. It's just another way to combine our functions. So the definition is a composition of a function f with g is, we read this, f of g. And that is equal to taking function f and putting function g into function f. So, like it says there in English, we're putting one function inside of another. This is called a composition. Your domain is going to be the set of all x in the domain domain of g such that g of x is the domain of f of x. And we'll talk more about that. So let's look at an example. We want to use f of x equals 2x plus 3 and g of x equals x squared minus 3x plus 2 to find f of g and g of f. So, f of g. We are going to just take function g and we are plugging it in to function f. So, we're working from the inside out. So, start with function f. We have a 2. Well, right away we see x. That's where we need to plug in function g. And then finish writing f. Next, simplify. So we just have to distribute. And then combine our like terms. So we would say f of g of x is equal to 2x squared minus 6x plus 7. Well, now we need to find g of f of x. So we're going to take f and put it into g. So right away we see an x and g. So we need to put in our 2x plus 3 squared. Continue with g, so minus 3. We see x again, so that means we need to put in f, which is 2x plus 3 plus 2. Well, remember this means FOIL, so let's just FOIL up here to save some room. So we have 2x plus 3 times 2x plus 3. So that gives us 4x squared plus 6x plus 6x plus 9. So that gives us 4x squared plus 12x plus 9. And now we can do some distribution. So we have negative 6x minus 9 plus 2. And combine your like terms. So we have 4x squared minus 6x. The 9's cancel out, so we just have plus 2. Okay, we need to now, on our second problem, we want to look at the domain of f of g of x and then g of f of x. So first, we're going to take f and we're going to plug g into f. So we have 1 over, and there we have our g function. Now, your domain, we can have it be all numbers, but think about this. You can't have a 0 in the denominator. So we have to figure out when would x plus 2 equal 0. Well, that occurs when x equals -2. So that means we cannot have, or our domain, we would say, is all real numbers. There's your all real number symbol, such that x cannot equal -2. So it's all real numbers. This line here means such that x cannot equal -2. All right, let's take a look at g of f of x. So now we need to plug f into g. So we have 1 over x plus 2. Well, in this case, what would your domain be? Once again, all real numbers such that x cannot equal 0, because we can't have 0 in our denominator. All right, let's try some basic compositions. We're going to be adding. So we want to take f plus g of x. So we're leaving this in terms of x, which means when we find f plus g of x, we're going to take function f, which is 3x minus 1. We're going to add it to function g, which is x squared minus 4. So combine your like terms and simplify as much as you can. And we should find that we have x squared plus 3x minus 5. Okay, how about f minus g of x? You got to be careful on this because that minus makes a difference. So we have 3x minus 1 minus x squared minus 4. So what's the first thing we should do? Distribute that negative. So we have 3x minus 1 minus x squared plus 4. So then f minus g of x is equal to negative x squared plus 3x plus 3. Now, the last one is a little different because notice there's not an x anymore. We now have 5. So we need to plug a 5 in wherever we see x, and we're going to take f times g. So we have f times g of 5. So we have our function f with a 5 plugged in for our x times function g with a 5 plugged in for our x again. So we have 15 minus 1, and we have 25 minus 4. So this gives us 14 times 21. So then we can find 14 times 21 will give us 294. So f of g, or f times g, sorry, of 5 equals 294. Right. Few more. This is our last slide. So once again, this is back to some compositions. So we want to take function g and plug it into f. So let's write it up here. F of g of x. So I'm taking function f first, which is going to give me 3. Right away I see my x, so this becomes x squared minus 4. And then minus 1. So f of g of x equals 3x squared minus 12 minus 1. So f of g of x equals 3x squared minus 13. Well, this is just a different notation, but this still means that we're going to take g and plug f into it. So, g and plug f into it means that we're going to have, right away we see x squared, so this becomes 3x minus 1 squared minus 4. So, I'm not going to show you the FOIL work. Hopefully you guys can figure that out, but you should end up with 9x squared minus 6x plus 2, and then minus 4. So g of f of x equals 9x squared minus 6x minus 2. And the third one, f of x, which means we're just going to take f and plug it into itself. So 3 times 3x minus 1 minus 1 gives us 9x minus 3 minus 1. So f of x equals 9x minus 4. All right, I'm going to clear this writing. Remember, you can always pause. To find f of g of 3. This is the same as taking f and plugging g into it with replacing our x with 3. So let's first find g of 3. Well, g of 3 would be 3 squared minus 4, which is equal to 5. So now we're going to take f and plug in 5. So 3 times 5 minus 1. So f of g of 3 is equal to 14. Notation looks scary, but it's not too bad. So in summary, we are combining two functions into one. We are just evaluating the functions as well at a given point. Please make sure to bring your questions to class.